Welcome to a preview of today's workshop, leveraging Derek's Integrated Fraud Management Suite to enhance fraud and financial crime detection on cross-border payments and messages represented as SWIFT transactions and other interbank communication. Fraud in real-time payments is a rapidly growing and serious threat that forms a major portion of the global threat landscape. Unfortunately, banks often struggle to deal with the real-time nature of this problem and to detect, prevent, and mobilize a response in real time, owing to the sparsity of data contained in SWIFT message fields, such as in an MT103, the need to integrate a holistic picture across multiple data dimensions, including client, counterparty, transactional metadata, internal digital indicators, and possible external sources of data. And finally, the need to identify the false positives and to remove those from the signals that are generated to the rest of the organization. Derek, in partnership with Wipro Technologies, a global professional services firm specializing in IT services and IT systems for the world's leading global financial institutions, has pioneered a proprietary intelligent platform that integrates with core banking systems and existing fraud detection architecture to provide real-time detection, scoring, and integrated prevention strategies to the bank. The intelligent platform uses a topological analysis to separate normal activity from abnormal activity. And it uses a data model known as the structured transaction ontology, a unique and proprietary data model that integrates features extracted across multiple data dimensions: client, expected activity, historical activity, benchmarking against peer groups, benchmarking against clients that are similar in the way they transact, counterparty resolution through an industry-leading entity resolution engine powered by a recurrent neural network that identifies, using the name and address information from the message fields, the most likely match based upon historical transactional data and expected fit to the client's profile. An ability to extract attributes from transactional metadata, such as information about changes to instructions, changes to particular components of the transaction, such as the account number and the banking information or the address, or other data that may correspond to events that correlate to anomalous activity. Internal indicators of compromise, such as credential compromise or event logs that register an anomalous pattern for an organization, a device, or another shared resource. And many other external sources of data that help to profile suppliers, merchants, transactional counterparties, and clients better to understand risk indicators, both with regard to the endpoints of the transaction, the client and the counterparty, as well as intermediary banks, correspondent banks, and other banks that may be associated with known threats, represented as non-relational, graph-based stories involving complex interactions between actors, such as state actors, corporate actors, individual actors, and other entities. What does this look like in a real example? Well, we can take a look at an example of a typical transaction. In this particular case, we have a great deal of information about our client, who is in fact a corporate specializing in industrial fabrications and tools, and who transacts with a particular type of counterparty set. We see here that instructions have been submitted in the form of an MT103 with no intermediary, requesting the remittance of funds, $37,372.45, to the Bank of China. Based off of the sparse data that we have, the engine is able to, in real time, already assemble a real-time payment intelligence score, as well as a set of factors that are associated with known threats. For example, anomaly detection on the particular behavior of this client, which is out of sync, according to our topological model, with other similar clients who typically transact with suppliers that are categorized slightly differently. This flag is correlated to other flags that are identified, where the categorization of this counterparty as a specialized exporter of tools and hardware based off of information we're pulling from the client's own data sources is at odds with our predicted categorization based off of the information about the entity that is available through our recurrent neural network search as an undeclared reseller, broker, or distributor of multiple product lines. Essentially, that this exporter or counterparty may not be quite what they seem. And of course, we also have some adverse media associated with the beneficiary bank itself and the specific branch, including an ISAC alert. However, this is not enough to create that holistic picture that correlates multiple events across multiple dimensions and different data sources to come up with a real-time weighted fraud score. So let's see how that score is generated over the course of this transaction and is updated at every stage in the life cycle of this payment, from the initial screening, which has already taken place, all the way out to origination. As we can see here, we already have some of the flags as well as some of the data associated with this exporter. Our superior counterparty resolution enables us to profile payments that have been associated with this beneficiary in the past, including those that may not necessarily originate with our bank, but are to be found in U.S. customs data and other external data sources. We also already have a view of some of the risks, but the holistic picture is to be found in the transactional risk assessment, which looks at everything from behavior expected for this client, expected counterparties, and the categorization and risk indicators surrounding the counterparty, as well as other factors that are more linked to digital exposure that the bank, the client's bank, meaning us, the counterparty bank, the counterparty, or the client may be exposed to. We can see here that some of the more salient features in this case include possible cyber attack vectors within the bank itself that correspond to an attempt to approve a particular transaction or payment that may in fact be illegitimate. Additionally, exposure of the counterparty's bank, in this case Bank of China, to known instances of compromise or fraud are clearly relevant in assessing the score. Some of these features and components of the overall score are already available to us because we have some information, and some of them are not yet quite apparent. Known threat matches, of course, are in fact based upon a complex and proprietary representation of known hybrid threats, interactions between states, corporations, individuals, and other entities in the threat database that allows us to update a real-time global threat profile. We also have extracts from event logs that are processed into what we call deep feature extraction, a feature extraction process that uses deep learning to identify the most salient components of the structured transactional ontology. These specific attributes correspond to anomalous profiles in the event logs that are emitted from the approval process internal to the bank, suggesting possible compromise of an insider or of an organization. We also have attributes associated with the transactional network of the client, as well as the transaction lifecycle, changes to the instructions, invoice changes, other information surrounding possible tampering or modification of resources, the way in which this transaction has been requested, the information and metadata surrounding the context for this transaction and its progression through the lifecycle. All of these are equally relevant when attempting to identify wrongdoing. And of course, missing data elements that are typically associated with a normal profile. All of these attributes are condensed into our structured transaction ontology, our proprietary representation that enables scoring and differentiation of normal from anomalous while incorporating multiple dimensions and multiple sources of risk into one complete story. This can then be used to identify and to mobilize the right resources within the organization in an automated way to generate a response in real time at any point during the transaction lifecycle. And as we get more and more data and progress through the lifecycle of this transaction, for example, receiving invoice instructions, and updating the results accordingly, we see that the risk profile becomes more rich and more valuable in generating a real-time score. We look forward to showing how this workflow provides the capability to, in real time, screen a transaction and to stop suspicious transactions with minimal impact on a client's legitimate transactional journey. Thank you very much.